Oh, Merry Christmas to everyone. Here we have 4 questions on how to model fractions, integers, and algebra. So we have 1 from fractions, 1 from integers, and 2 from algebra. So we're going to start here with the first question, which gives us this picture and said, what is the equation? And back in the day when we learned how to do it, we say, well, we start with 2/3, and this line cuts that fraction in half, and a check mark means we get to keep half of it. So what this really says is half of 2/3, and since we already discussed it 1,000,000 times, half of 2/3 mathematically expresses half times 2/3. And when I work it out, I get 2/6, which in lowest terms is 1/3. The same thing here, I would get 2 parts out of 1, 2, 3, 4, 5, 6. So 2/6 is your answer, or 1/3. In the second question, we started off actually with the number 0. All of those 0 pairs put together, no matter how many 0 pairs we put together, it will always equal nothing. So we started with nothing, and from that we removed 6 groups of +3, or removed 6 groups of +3, and when we did that, what was left was just 18 negatives. So our equation is -6 times +3 equals -18. Our next question gives us a algebra question that's modeled. Now, one of the things you had to pick up on was that this here and that this here are not the same thing. One is a negative half of x and one is half of x. That little negative sign means that it's a negative half of x. So when I write that, there's 3 ways I could write it. I could write it as a negative half of x, or I could write it as a negative half of x, or I could write it as a negative half of x. As we've discussed before, the easiest way for us to start with that is going to be putting our negative sign for a negative half of x in our denominator. And the reason why we want to do that is because it makes it much easier to isolate using opposite operation. So a negative half of x minus 2 equals 1 is the proper interpretation. So once we have it interpreted that way, it's real simple because we just have to apply opposite operation. If it was the modeling, I would add 2 to both sides to get rid of the constant. Here I'm just going to add 2 to both sides. And when I do so, I'm left with a negative half of x equals 3. I'm going to multiply both sides by -2, which is the part in this thing I can't really double negatives to get positives because it doesn't make sense. So that's kind of where the modeling kind of falls apart. When we do, we get, with opposite operation, we get x equals a -6. 3 times -2 is -6. And our last question, we have these here. Now remember, this is a positive x, and this is a negative x. So when we look at this particular modeling, it actually says -3x plus 1 equals -5. Once we've interpreted it, we're just going to apply opposite operation to get -3x equals -6. And then divide both sides by the -3 coefficient to get the answer of x equals a +2.